Hi everyone. This is example 4 for the supplemental topic involving discrete random variables from your student packet. It says a game costs $5 to play. You draw a card from a deck of cards. If you draw the ace of hearts, you win $100. For any other ace, you get $10, and for any other heart, you get $5. If you draw anything else, you lose. Find the average winnings or losses for this game and the standard deviation for the distribution. So, first of all, notice that it costs $5 to play. So we have to take that into consideration for all of our outcomes. We're dealing with a deck of cards. There are 52 cards in a deck. And a deck of cards has 4 suits: aces, diamonds, spades, and clubs. And for each suit, there are 13 cards: the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king. So what we want to do with this problem is we want to create a valid probability table. So we're going to start with the outcome. And the first outcome that we could do is we could draw the ace of hearts. And the payout for that, well, we would win $100, but don't forget that we spent $5 to play the game. So we'd walk away with $95. And the probability that this happens, well, there's only one ace of hearts out of the 52 cards, so this would be 1 out of 52. So the next outcome is that we have some other ace. Well, there are 4 aces in the deck, but the first outcome dealt with the ace of hearts, so there are only 3 aces left. So I'm going to jump to the probability. The probability of drawing some other ace would be 3 out of 52. We'd win $10, but remember that we spent $5 to play the game, which means we'd walk away with $5. Now the next one is that the next outcome is that we would draw any other heart. So remember there are 13 cards for each suit, but the first outcome had the ace of hearts, which means there are only 12 other hearts left over. And we'd win $5, but we paid $5 to play the game, so we'd really walk away with nothing. And then finally, the last outcome is that we'd draw any other card. Now, if we draw any other card, we're going to lose, which means that we're down $5. So this is going to be a -5. Remember that this needs to be a valid probability table, which means our probabilities need to add up to 1. So since we have 52 cards, let's take the 1 plus 3 plus 12, which is 16, subtract it from 52, which means we have 36 cards left over in the deck. So there's our probability table. We want to find the expected value and the standard deviation. So I'm not going to do this by hand. I want you to use your calculator. So again, I can't show you my calculator because I cannot get an emulator on my iPad. But you're going to put the payout in L1, and you're going to put the probability in L2. And then you're going to go to Stat, Calc, and you're going to choose 1 var statistics. Your list will be L1, and your frequency list will be L2. Now, if you have a TI-83, you're going to go to 1 var stats the same way, but then you'll end up with a parenthesis. So you'll do L1, comma, L2, and close your parentheses. Then on your calculator, you're going to look at X bar, and that's going to give you the answer for the expected value, which we are going to use as mu because this is a model. Sorry. And then I lost my page here. When you put this in your calculator, you should get a mean of negative 1.35. The standard deviation is going to come from that like sigma s, I think that's what it looks, sigma x. I'm like blanking now. So this is the standard deviation of x. And on this we'll get $13.80. So what does this mean? This means that on average, I'm having a hard time writing here. On average, you will expect to lose $1.35 overall. So if you were to play this game many, many, many times, that would be your average.